This lecture we're going to get into looking at, again, computer solutions, but now we're actually talking about more mesh equations. And now we're going to be, this is going to be again a question of how do I solve things in a computer, and basically what I mean by that is writing things as matrix solutions. Because typically when I'm looking at structures, say like SPICE or something else, I'm going to be using matrix type solutions. Or maybe I want to write something down in a certain form that I can have MATLAB solve it, or a similar like MATLAB-like engine to work with this. So this is what I want to look for. There are two ways to do this. One is going to be looking at nodal equations, which is basically looking at Kirchhoff's current law, which says look at every node and then kind of write the equations down and eventually get a linear system. Or you get an equivalent linear system to solve for various currents or voltages by actually looking at meshes. And this gets a little bit more complex, but it's kind of valuable to think about. And again, the big reason you do either of these is because you may need to do a computer solution, but it also gives you some good intuition for anything circuit you might be building or might be analyzing, and it might be using some other technique, but it gives you some other pieces of just sort of guidance. And every bit of intuition you can learn about solving circuits is really helpful. You'll probably have your favorites as you start to develop things, but it's good to have that intuition of all of these to use at any given time. So what we're going to look at typically here now is meshes, and it's going to be very important to get a sense of what these meshes mean. We're going to be typically looking at meshes, and it's going to be KVL around a single mesh. All of them have to be done counterclockwise. This one actually was done the other way, so that way you can kind of think about this as we're working through it. But if I write KVL around this mesh, there'll be a voltage here, and then a voltage increase, a voltage drop, and a voltage drop. You can kind of see this in how the first mesh is written. You can see a similar thing for I3. There's a voltage. Is effectively when I go up through here, there's kind of an increase, a decrease, and a decrease. In this case, I would also have a mesh which would then go in this direction. It's kind of a decrease, and an increase, and I have to kind of keep all the signs balanced. And so I can kind of do this. Now we can kind of walk through and do all the math, and I kind of walk through that here in these three meshes. The reason you'd go through this, or what reason we would look at this and understand the rules carefully, because I could write KVL in any way I want and then write the equations and solve them. That's great. But this system, much like what I would see for the nodal equations, is that there's certain rules that pop out. And one of the ones that's interesting is on the diagonals, the resistances that I would have, which are all positive, are going to be the sum of all of the it's going to be all of the sum of the resistances in the mesh. So you can kind of see that in all three of these in terms of where those terms come through. And then the other terms are the cross terms in the meshes, the things that are shared between two meshes. So you have a shared between I1 and I3 is R2, and between I2 and I3 is R4. Now I have to get everything in the right order, which is why I2 is inverted. I wanted to kind of just make you think through that question a moment. But then when I do that, I can kind of write these equations down in a very systematic way. And then I can solve for V, basically a matrix version of Ohm's law, V equals IR, and basically invert the matrix and pursue and continue that way. This matrix for R is always positive definite. It is symmetric, much like I would have for a nodal case. The diagonals will always be bigger. All of the off-diagonal terms will always be all non-positive. And this really allows me to kind of talk about these various kinds of solutions. Again, solutions, trying to come up with a computer-generated version of this in one form or another.